Okay, let me share my screen. So can you, yeah, you can see it. Okay. So as in the configure Git, we own these 8 categories, but actually we don't even consider some of these, like ChatOps, serverless, cluster cost management are basically totally out of focus. We don't do anything in that for various reasons. The other ones are kind of in focus, but we are actively always trying to focus only on a single category. And the others are in maintenance mode. I might run user interviews. I'm open to customer calls, but we don't dedicate development time to those except for bug fixes maintenance. So right now, our focus is 100% on Kubernetes management. And we are actually preparing what we call here delivery management, or I would rather call it deployment management. That's what we are preparing as we speak, together with the release team. And that I found super exciting, but I will try to focus on the current roadmap. So basically, since the release of 14.0, that is almost like 2 months ago, we are focusing only on Kubernetes management. But even that, we were focusing on Kubernetes management and infrastructure as code together, a little bit of secrets management as well. This very strict focus on a single category is in the past 2 months, and will continue probably in the next 3 months, as I guess. But that's really a wide guess, because it really depends on the teams, how they deliver what I want them to deliver. And this is the next topic. What do I want to ship in this time frame? Basically, how I approach the whole area is that we restarted the Kubernetes integration of GitLab a year ago, and a few months ago it started to form what would be a reasonable scope to say that, okay, now this is a nice chunk of feature, what I started to call a nice category iteration here, that we can put aside this category for a little bit and focus on other categories as well. And once the scope started to form, the first thing that I did is I collected basically all the ideas that I had at the time and created what you can see something like the opportunity canvases, but it's really in a format that helps you to have an overview of the different opportunities one by the other, and have them have an argument about why would you prioritize one above the other. So that's what I did. I even shared this with a few customers to discuss whether they understand the topics, to discuss whether they agree with the prioritization. It was very interesting to see that there were actually I had 3 calls around this sheet that I'm just sharing with you, and there was one who said that he personally is not interested in one of the elements, but 100% agrees that it should be there. That was very interesting, that he said that they know that they have a very special setup, and that's why they don't care about that one. But this is really very similar to the opportunity canvases. There's a huge amount of comments to many of the I wanted to scroll down here. So to many of the slides, there are a lot of comments as well. But so this was a collection, and then out of this, I created a maturity plan. And this is what I shared yesterday in the S-configure channel as well. I would consider our category complete if we can serve these set of features, use cases, teams, topics, whatever you call them. And I think where should I start? Because I don't know how much you know about the current category, like the whole agent thing and so on.
Victor, maybe I would, if it's possible, given we have at least 2 new members on the team.
Yeah.
If you maybe just describe the vision of Kubernetes management,
Yeah.
where we came from with the previous integration, and
Yeah.
what we have today, and then jump into why this list of things are there. That
Yeah, I just realized the same, that probably I should start a bit earlier. So we had a Kubernetes integration, I think from GitLab 11.0 perhaps, so quite a long time, or perhaps it might be even 9.0, a long time ago. And that integration uses some cluster certificates. That basically means that you have an API for your Kubernetes cluster, what we call the Kube API, and you get a token and a certificate to authenticate with that API. And you basically tag GitLab that, look, GitLab, you can reach my cluster here and authenticate with this token to access the cluster. And then all the logic was run within GitLab to call out into that API and manage your cluster. This is the what I would call legacy way or certificate-based cluster integration. The reason that we are trying to move away from this is primarily driven by security. Especially on GitLab.com, our users are not happy with this setup, because to use this setup, the Kube API has to be accessible to GitLab. And that means that they have to, in a way, open up the very internal API to the internet, or at least whitelist GitLab IPs, so that they can access their clusters from GitLab. Of course, there are kind of workarounds around this. The most typical one is that they install runner fleet within their VPC, and then they just need local access. But in that case, they lose all the integrations that GitLab would offer for Kubernetes, because only deployment happens through the runner and nothing else can reach the Kube API there. So this is where what the situation was a year ago. And we decided to restart this whole Kubernetes integration approach with an agent-based setup, in which case I'm going to open the docs here. And I will need to make a few clicks to show you what I want to show. Basically, we said that let's build an agent that sits within the user's cluster, and the agent reaches out to GitLab to set up the connection. So from this time on, this cluster should not be opened for GitLab to reach its API, but we have an active component within the cluster. That active component, by definition, can reach the API, and it reaches out to GitLab, which is in a sense a bastion host or something like that. So this agent sets up a bidirectional channel, actually. As a result, once the channel is set up, initiated by the cluster set component, even GitLab can start sending messages, as it's a bidirectional channel. And this just opens up a huge new set of possibilities for us. The first team who saw this is actually our container security team, who added, for example, Cilium network security policy integration to the agent, which means that if the cluster runs Cilium, then you can configure container network security policies from GitLab in the cluster. And if there's an alert, the alert is surfaced into GitLab, and an issue is created automatically. So this is really the power. The agent is just a basic building block for any type of integration. And one thing that I told Kevin for a long time, that I think that configure, monitor, and release should work together, because even the monitor features within GitLab are built around the legacy integration, or even without the legacy integration for for Prometheus. And this enables, let's say, new possibilities for monitoring your cluster as well, because GitLab lives within that cluster. We can run queries directly in that cluster. The cluster can reach out with alerts to GitLab and so on. So I think for the monitoring side, this is an important change and a totally new set of opportunities here. For deployments, again, this provides new opportunities. Like before, you could only deploy to a cluster using GitLab CI/CD, which meant push-based deployments. And there's a huge hype around pull-based deployments. Part of that hype is reasonable. Like it's much better for platform engineers to define the basic tooling they want to run in a specific cluster. And this was a use case that we could not support at all with the previous approach, and we can do support that with the agent-based approach. So this is what we started to build out. The agent is just an active component within the cluster. That's the basis, the foundational layer of every GitLab to Kubernetes integration. That's the idea. It's in itself, it's featureless. And we built a couple of features already on top of the agent. One such feature is pool-based deployment, which means that you have a repository where you describe your Kubernetes resources. These mean usually YAML files if you are not familiar with Kubernetes. And whenever you change that repository, the agent is notified. It grabs the manifest and pulls them from GitLab into the cluster and applies them in the cluster. This allows as well automatic syncing. So if somebody changes something manually in the cluster, the agent will realize that, oh, my definition differs from what's in Git. So let's get what is in Git. And this way, the cluster is more immutable. It's more locked down. And all the changes are better monitored and followed and more compliant usually. Besides pull-based deployments, we have push-based deployments as well, what we call with the CI/CD tunnel. This was released, I think, in 14.1. So the CI tunnel actually connects the agent through CAS with a runner that can run anywhere, which might run even on GitLab.com. It might run in an AWS VPC while your cluster is on-prem. It's totally up to you where these things run. And this way you can do push-based deployments as well from GitLab CI/CD into the cluster. You can run any of your favorite tools, or you can auto DevOps or whatever you want. And besides this, there are other integrations that were provided by other teams, like mostly the security team.
Hey, Victor, I'm gonna hit pause to ask some clarifying question. So Kubernetes management at its core is a customer, a user decides that they want to run their software in Kubernetes, and they need to do all sorts of things. They need to be able to deploy to Kubernetes. They need to be able to understand what's going on in their Kubernetes cluster. They need to potentially do things like manage the cost of running that cluster. They need to do things like enable teams to have different namespaces for their different application, et cetera, et cetera. There's lots of jobs to be done. What you're saying is the agent is a single building block. It by itself has no specific functionality other than that it knows how to talk and interact with both the clusters and GitLab. And GitLab in this case is like a control pane or the knobs and switches that you can do things to the cluster with. So yeah, this is what Kubernetes management is all about. Is that accurate?
Yeah, exactly. So it's like I will get into more details around some of the jobs that Kevin just mentioned around access management and so on. But yeah, so basically, Kubernetes is a container orchestration tool, so to say, which means that it's a server on itself where you put Docker containers and it just scales them up, scales them down, manages access rights and networking around those containers and many other things. And all this management is actually done declaratively. This is one very special aspect of Kubernetes, that Kubernetes doesn't have a UI. It has an API, and people can build UIs on top of Kubernetes. Often even said that Kubernetes is meant to be a platform for others to build their own platforms for their own companies.
A fundamental question, which is, given that there's lots of like controlling things that control Kubernetes, what's our main selling point, in your opinion, today, for someone to use the GitLab control plane?
I think the main selling point is that we are integrated with your source code management tool, because GitLab, doesn't matter if we are happy about this or not, the vision is to have a single app for the whole DevSecOps lifecycle. But the reality today is that GitLab is a an SCM and CI tool. So it's source code management and CI, and that's what users are aware of. And we have to acknowledge this and have to build a more powerful funnel and a more powerful use cases built on this idea that our users have, the understanding they have about the product. So I think this is the biggest selling point. That another one which makes it very strong is that if you are a self-managed GitLab user, that means that there is somebody in your organization who installs and maintains GitLab itself. And usually that person is a platform engineer, which means that the job of that person is to maintain your Kubernetes cluster as well. So we are already in very good hands. There was somebody who picked us as their tool for source code management, for CI/CD, and that person is the one who manages their clusters too. So we are in a relatively good position here to speak to them, to show them that, look, guys, we have more to offer for you, specifically you who are managing GitLab in a self-managed setup.
So what would they be using without GitLab to manage Kubernetes? Or what are
Yeah. So as I said, the Kubernetes just provides your control plane, and it just provides you an API. And there is the stock tool to run commands against this API that's called kubectl, kubectl.
Yeah, I've used that in the command line.
Yeah, that's one thing. There is a tool called Helm that's often described as the application package manager for Kubernetes. Sorry.
Is that the same thing as like Helm charts?
Yeah, exactly.
Okay.
Yeah. In the end, everything here is hydrated into YAML, and the YAML is applied to the Kube API. So that's the end result of all these tools. The only question is the level of abstraction they provide on top of it. Okay. If we go even further from these basic tools that are really apply something to the cluster, there are one of the most famous tools these days is Argo CD or Flux CD. These are what are often called as GitOps tools. They basically do pool-based deployment and a bit more automation or visualization around those deployments. But the basic idea is that we can provide them a Git repo, and they just make sure that your cluster is in sync with that Git repo. And the Git repo can contain a Helm chart. It can contain pure Kubernetes YAML files or customize things. That's another tool in this tool set of deployment tools around Kubernetes. What are the tools?
Well, I've seen, so people sometimes manage their different Kubernetes clusters over AWS.
Yeah, so that's kind of correct.
Okay.
Basically, AWS, GCP, DigitalOcean, all the hyperclouds provides a managed Kubernetes service, which means GCP is considered to be the most mature in this one, but AWS is very, very strong already as well. The idea here is that you can build your own Kubernetes cluster even without, so you can,
I think
AWS has the managed offering, which is called EKS, but you can use EC2 instances on your own to build up a Kubernetes cluster within AWS. So this is already kind of starts to get confusing, but the basic idea is that you just create a server, let it be a Kubernetes cluster within AWS, and after that, that's a Kubernetes cluster with a Kube API, and what's inside the cluster is almost doesn't matter whether you are on AWS or on GCP. Why I say that it almost doesn't matter, because AWS, both GCP, so all of these hyperclouds have some level of integration with their built-in AIM system, and that's where they can provide integration out of the box, and they can provide integration in monitoring as well. So like Google Stack Drive, I think has relatively good integration with the GKE clusters that are run within GCP. For AWS, the CrowdTrail, I guess, doesn't have such a good integration, but you can integrate CrowdTrail as well with the pods that run in your Kubernetes cluster.
Okay. So if I were to, oh, go ahead.
No, just one sentence. If you would like to manage what's in your cluster, so like start a new deployment, start new pods, and all these things, I don't think that you can do that from within the AWS interface, actually.
Okay, so I think if I'm understanding it, GCP, these AWS, these cloud services are kind of like the infrastructure that can host the Kubernetes cluster, whereas the agent that we install can help provide a better interface with all of the different things that you would want to do actually within the Kubernetes cluster.
Correct. Yeah, that's the idea. Yeah,
okay.
Exactly.
Yeah.
Yeah. In terms of monitoring, like, I think that GCP has really good integration with Stackdriver. So I think there are a few people who use just that to monitor their clusters. So there, it's a big question, like, what can GitLab offer? And actually, we heard that even there, GitLab can offer a lot of things, because the developer is in GitLab. And I really like to differentiate three personas when I speak about all this area. I like to speak about the platform engineer, the application operator, and the software developer. And the only reason why I speak about the software developer, because everybody speaks about the software developer in GitLab, and I want to make clear that I don't care about him. He is not my persona. So I have two more: application operator and platform engineer. And a very typical use case that I've heard is that the application operator is part of the software development team, and they want to have insights into the applications that they just deployed, or they are troubleshooting or whatever. But the platform engineer doesn't want them to get access to GCP console for whatever reason. It might be too complex for IAM. They are a third-party agency that are just developing that single application. Whatever reason, they don't want to provide access to the GCP project. And in this case, they are really happy and are looking forward to have really good metrics and monitoring within GitLab around the applications that were deployed into a cluster, and only around those applications.
The application operator, is this person usually like the lead engineer in the team?
No, it's not actually. It's, I mean, yes and no. So, yeah, sorry, I would rather agree, because if we speak about a small company, then I would 100% agree. Probably the guy who takes care of the networking, builds up the infrastructure, and so on and so forth. That's a single person. That's the lead engineer, and he does all the platform work and application operations as well. In an enterprise setup, that might be a dedicated, what you might call DevOps person in the team. That is the application operator. it might not be the lead engineer. I would say that it might happen that he could be a lead engineer. He might be a lead engineer, but often he is not at all. Any more questions here or?
Hey, Victor. So wanted to understand a little bit more about the 3 personas that you just talked about. Could you elaborate a little bit more when you talk about how the software developer is not somebody that you're focused on?
Of course. So actually, I was the one who added here the 2 persons that I just mentioned, the application operator and Priyanka, the platform engineer. And when I speak about personas, I really mean the persona as it's meant in UX. So I know it might be that a single person might act as multiple personas. And especially in case of an application operator, it might happen that that person is a software developer and most of his work is around writing business code, but he's the one that's in charge of making sure that the infrastructure is okay. When there's a new deployment, the deployment works as expected. So the reason why the software developer itself is not, I don't consider them as a persona, because I think that the persona as a software developer is the one who focuses on creating the business application, to writing the code, making sure that tests pass, doing perhaps performance tests, but they don't do any day 1 or day 2 operations, even not day 0 really. That's the reason why I differentiate between these personas, because from ops perspective, they don't exist.
Okay, I appreciate that clarification.
Yeah, it's really, I just basically what I would emphasize is the last sentence that I said, like who does day 0, day 1, day 2 operations, who sunsets an application, that's the application operator, and that's not a software developer. That's the core, I think. Other questions or? Okay, then let me continue. So is there anything else I would want to say around Kubernetes management? I think not. So you've heard the basic ideas here, like there are the different personas, there's a lot of question, authorizations, and who can access what's in a given cluster. Specifically, like there's a specific question that in the dev environment, it might happen that everybody can access everything, even secrets. In staging and production environments, everybody can access only the namespace dedicated for their team, and they only have read access, but not for secrets, just everything else in that namespace, for example. So authorization rights are one central aspect of all of this topic. And the things we developed already are around this basic pull-based and push-based deployments. These are already shipped, the first versions of it. And one aspect of that is the CI/CD tunnel that I mentioned, that's for the push-based one, which today can only use the same service account that you install the agent K, this component here, into the cluster. Which means whatever this component is allowed to do, your deployment can do it as well. This is pretty insecure. As a result, we are currently developing features to make this CI/CD tunnel more scalable, in a sense to be able to set up at the group level on one hand, so you don't need one agent per project, just one agent per group, but as well to make it possible to say that this user who started the CI job has these access rights in my cluster, and impersonate that user when you do the deployment. Or this CI job has access rights in my cluster, and impersonate the CI job with those access rights when the job is run. And this way, the platform engineer can restrict the possibilities of any job or any user and any action going through the CI/CD in the cluster.
This is actually, so when talking about to customer about release, they constantly talk about separation of duties. So the person who builds something should not be the person that deploys at a large organization. Then with this setup, you have a single choke point to control access, which makes access control much simpler. You don't have to like figure out, oh, different types of roles that people need to belong to at different group levels. It's just a single service account that's responsible for deployment, and who can access that service account can be controlled more easily, which is nice.
Yeah. One more note here, which I'm not sure whether I'm happy about or not, is that you might have heard already that GitLab's roles are very limited and not customizable and so on and so forth. And here we actually escape this, because we say that you can use the airbag model of Kubernetes to manage who can do what, which GitLab user and which GitLab group can do what in your cluster. So we try to get around this, and we have actually an issue that's in the lovable phase, which would sync up the GitLab users and the access rights to the cluster to make this mapping between GitLab access rights and Kubernetes access rights. But right now, we make it more flexible in a sense. It's up to the platform engineer to set it up everything in Kubernetes using Kubernetes Airbag, but they can restrict it way better than it's possible within GitLab only.
Why do you say you're not super happy about it?
Because it's in a sense, it's a weird thing that we escape the limitation of GitLab and we don't solve Airbag within GitLab, but we just delegate it to the cluster. I think this is the right thing to do, but at the same time, it's a little bit weird. So this is what we are working on the CI/CD tunnel aspect. And very similar, we have an issue for pool-based deployments as well. Today, when you do pool-based deployment, you use the service account of the agent. Whatever the agent is allowed to do, if you put that manifest in your repository, it will do it. The idea here is to be able to restrict this again, to impersonate a specific set of groups or user or whatever, and run a given pool-based deployment using that airbag rights that you described instead of the agent service.
When it comes to auditing, like to find out who did what. So right now for pool-based, to check who made a change, you have to check who made the commit to the repository. Is there any way else to figure it out? That feels unnatural, but maybe I'm projecting.
That's correct.
Okay.
Even in the future, this will stay. So what we want to do, but that's a good point, because we might be able to make it more dynamic. The idea what we have is to say that, so this is how you describe which project you want to deploy. This would be manifest project 2. And this is a project where you have this Kubernetes resource manifest, these YAML files that describe what you want Kubernetes to do. And the idea would be to impersonate a specific name with a specific groups and keys. And then you can use Kubernetes Airbag to regulate the access rights of this name, these groups, and so on. But it doesn't include the name of the latest commit or who made that commit or stuff like that. But that's a good point that it might be feasible. I will add a note about this. Sorry, right now.
Your dog likes the fact that, or someone's dog likes the fact that the snow's being taken right now.
Yeah. Okay. Let's get back to the directions. The first item is actually pretty minor. It's more of a low-hanging fruit for us that can be really handy for many users. The idea here is to access your cluster, you have to access the API of this cluster. Especially today, if you are in lockdown and this cluster is in the VPC, you have to get into that network to access the cluster. But if you're on GitLab.com, you can access CAS anyway. And you might not even know whether this cluster is in AWS or is in GCP or where it lives. So it's you have to learn all these things. While CAS is always just CAS. So we had this idea that what if we could provide this local access possibility to users using the personal access token, for example, and an agent. So you would have your local computer here that reaches out to CAS and connects to cluster to do whatever you want, to run a kubectl command, for example, or ham apply or stuff like that. And
one point of clarification, CAS, well, and Alana means Kubernetes Agent Service.
So that's
yeah.
what the agent in Kubernetes pushes to in GitLab.
Yeah, CAS, exactly. CAS is the GitLab side component. And actually these two together, Agent K and CAS, are what we call the GitLab Kubernetes Agent.
Okay.
And based on what you're describing, Victor, is like it makes not only it's like a single interface, but it's potentially a way to help users transition between cloud providers, because it's like your interface remains the same no matter what.
Yeah, I don't think that this level of cloud neutral approach is actually valuable for many users. So based on the interviews, they don't plan to move or not looking into this. But yeah, otherwise it's correct. Another reason why I want to ship this is because as our users are looking into these integrations, that they would like good Prometheus integration, Grafana, whatever tracing tool, or they use just ERK for metrics. And even if you have Prometheus integration, it won't help them. With this, we can tell them, use your favorite tool. Let it be a CLI tool, whatever you want. You can use it from your local computer because we give you the kubeconfig that connects you using your GitLab username to the cluster. And that's why we think it's actually pretty valuable, because it just gets ahead of all the features. It makes them available to our users without us developing the features. Actually, they just have to use these third-party tools that they likely already use today. The next item to reach completeness is actually to have some management UI around the agent. Even today, to start using the Kubernetes agent, you have to run GraphQL queries. It's definitely a poor user experience. There's nothing to say about that. We want to improve this, not just the registration flow, so that it's much more pleasant to get started, but as well the troubleshooting of the agent. So we want to provide you a status of the connection. We want to show the latest events that the agent run within your cluster, or if there was some error between the connection itself. We have an idea of something like a status page that many tools provide, where we could show you not just what you set up, but we could show you as well that you don't have container network security policies because you are not an ultimate customer. And this way, we can even actually upsell features in a sense, and not just show that CI/CD tunnel doesn't work because you did not set it up. So these are the.
I have a basic question, which is, today we have a goal of increasing user adoption of our agent. And the reason today that anybody would want to use the agent is primarily pool-based deployment. That's our. Is that the?
True.
It's not true. What? do they also want to use the CI tunnel for push base? Is those two things?
Actually, there are three things that I've heard on user calls that they want around Kubernetes integration. One is pull based, other is push based, and the third is metrics and logs. These are the three requests that came back to me all the time.
Okay, but we don't have capability around metrics and logs yet. Or can we do something about it fairly easily?
We have that's what we are looking into.
Got it. Okay. And would you prioritize the agent management UI bits before metrics, or you think we must have metrics and log first before there's enough meat around agent for people to adopt?
Yeah, I would start the agent management UI first, because
okay.
I think that if I approach it from persona point of view, then the platform engineer who sets up the agent, they want insights into how it works and whether it works and these things. And today this is just super hard to get. So you have to switch between GitLab and your cluster, and just showing your single pane where you get this information. I would prioritize that. I might not want to ship all the management UI ideas we have actually, but definitely the basic troubleshooting ones, I would like to have them. Let me turn the discussion to metrics, resource dashboard, and log tailing. I like to speak about these three together, probably because I'm not knowledgeable enough about the space to speak about them separately, and because most of the time I hear about them together from our users. I consider these from a troubleshooting point of view, primarily. That's what I hear about. So it's not about incident management, but troubleshooting. And we don't have a good idea yet how to do this with the agent. The reason is that today GitLab offers a few views around all of these. There is an environment, there is the deployment environments menu, where sometimes you might be able to see Kubernetes related resources. Most of the times you will just see errors, and sometimes you even shouldn't see them because it's not Kubernetes related. So it's a really poor user experience that we have today, and very brittle in its functionality. From that UI, you might be able to go to the log tailing or both to the metrics integration, or you can go that even separately. But again, all of this depends today on the certificate-based cluster integration that I called legacy, and that we slowly want to roll out as the feature, as the agent becomes able to provide these features. And our ideas around this is, one is that, okay, what if we just change the backend, and instead of the certificate-based integrations, it will use direct connection through CAS to the cluster and do all the queries. This seems to be a feasible approach. It will likely take us 3 months. And right now we are blocked on infrastructure, but slowly we are progressing there. So this is one idea. But the other idea was that, couldn't we make something faster, something that might be even more awesome, simply because our Kubernetes dashboard built into GitLab is super limited. And there are Kubernetes dashboards out there that are way more powerful. There is actually even an official Kubernetes dashboard. And what if we could provide a UI that ships together with GitLab, but is in a sense outside of GitLab, like the Web IDE or the GraphQL editor are outside of GitLab. I don't know if you ever noticed this, but I will try to show the GraphQL editor. There is no even GitLab logo here. So what if we ship a Kubernetes dashboard in a very similar fashion, that it just, besides GitLab, you can choose which agent you want for your connection, and then it shows you the resources available there, and we just use an already existing, really powerful dashboarding tool out there. So these are the ideas that we are looking into, whether changing the backend or having an alternative approach that we might be able to ship way faster because we just reuse an open source tool. That's it. And actually, as I said, to me, especially log tailing and the dashboard go hand in hand. I can hardly imagine log tails without seeing the resources and without saying that this is the pod that I want to see the logs of. Metrics is a little bit different, but I usually speak about these three together.
To make sure I follow, the dashboard is necessary because that's how users, when troubleshooting, will navigate and get to and pinpoint the thing they're interested in looking more deeply into. Hence, you can't separate the three of them.
Yeah, I mean, you can separate metrics because so the dashboard shows you the resources that were deployed. In Kubernetes, every resource has a kind. Like you can have a deployment kind, a pod, a replica set, a job, an ingress. All these are just resources. And that's what a Kubernetes dashboard should show, that give me all the pods in that namespace or all the config maps or whatever. For the metrics, it's very different because there you want to see the nodes, for example, that your cluster is composed of, and you want to see the CPU utilization. Of course, you might want to see as well the error rates for specific pod or specific deployment, but those are already a bit different aspects there.
Yeah, that's interesting because we're talking like the words can mean different things. Metrics, we're specifically talking about metrics associated to your cluster, not necessarily always just not necessarily in this case, the application metrics. Because in a pure monitor world, what you want to do is go from, oftentimes you want to go from an application metrics, for example, the time it takes to run a certain process gets longer, then you want to go from that and jump into your logs to find out what's going on when that happened. But you're talking about at a higher level, it's the cluster, how it's performing and behaving.
The nice thing is I know that I'm not an expert of metrics, so I don't know. It's the application metrics are definitely valuable, and actually that's what our users are asking for. Just in my understanding, these are different tools for me, at least.
Got it. Okay.
So it seems like line item number 6 and line item number 8, so metrics integration and log tailing could have some dependencies or overlap with some of the things that long-term we'd be doing for monitor.
Mm-hmm.
Okay.
It totally depends on you.
Okay. All right.
The reason why I'm super happy to speak about these things, because I know that we want to work on the Kubernetes dashboard. And I think that's already an area where one can say that that's monitor, one can say that that's configure. So I think it's very important for us to know about each other, what we plan to do and how we want to do that. And as I said, whenever I speak about the resource dashboard, I very quickly turn to logs as well, because if I see the pods, I want to see the logs of them too. For metrics, that's a little bit outside for me, at least. That's how I approach the topic. But yeah, so we want to work on this in the next 3-4 months, as I said, because as you can see here, all of this I consider to be needed for a complete offering. I don't know if you can see that, but everything here is to reach complete maturity.
One thing to note, I see at least, so when it comes to metrics and logs, there's the open question to me right now is where do we put these things? Previously, we had the Prometheus and the Elk stack that you can deploy to your cluster to be the database to collecting these things, we've changed direction on that. We don't necessarily want to run that today. So what are the options? To me,
Actually, that's an option still.
that's right, because you can always just do that. Because and then you can connect it to via our agent. But
that's one of the options, exactly. One of the options is that you use a cluster management project, you install Prometheus Elastic Stack using the cluster management project, and then the option there is that we change the backend that we have today and provide you a dashboard that uses the agent for the connection instead of directly accessing the Kube API.
Perhaps I'm lenient. I would say from a product direction, that's not necessarily where we want to go in the future. I think our intention, or my personal opinion at this point, is we want to have a more of a managed solution of things like Prometheus and whatever log things and whatever tracing are in a single package versus something that exists separately. But that doesn't preclude it from being a solution here. And then we also know, of course, users love monitoring vendors. They love their SaaS solution. And typically, if you have similar type of data, they want these data to all end up in the same place. So whether you're using Datadog or Splunk or whatever else,
yeah,
like they want this data to show up there. So
actually, yeah, just one minor note here is that I'm very precautious to always speak about log tailing only and not log search. One of the reasons is that I know one thing about log search, that it's super hard. You have to store those, you have to store the logs, index them, etc. I'd rather stay with the tailing, and for the troubleshooting purposes that I'm looking at, this is probably enough most of the time.
Hey, I just looked at the clock. We're at time. Victor, thank you so much. Do you have any last minute wrap up thoughts?
No, if you have any questions or something, just feel free to come to ask them.
This was super helpful for me to see kind of the different things that you're working on and where the overlap is and better understand configure. So thank you.
Sure. Thanks.